Welcome to a masterclass on the substitution method. The book tells us, this method is used when one equation contains a unit quantity of one of the unknowns, as in equation 2 of the example below. Let's learn to think like mathematical detectives instead of blindly memorizing algebra recipes. Let's look at our example setup exactly as written in the textbook. Equation 1 is 3x minus 2y equals 0. Equation 2 is 2x plus y equals 7. Our mission is to find the exact values for x and y that make both statements true at the exact same time. First, a golden rule from the textbook: label the equations so that the working is made clear. If you don't organize your variables clearly, you'll easily get lost in your own thoughts. Let's assign clear tags right now. Now, look at the two options. The textbook says, in this case, write y in terms of x from equation 2. Why? Look closely at equation 2. The variable y is completely alone, it has a secret invisible coefficient of 1. It is a perfect unit quantity. Let's isolate our target. We take equation 2, 2x plus y equals 7. To get y completely by itself, we kick the 2x over to the other side by subtracting it. This gives us our brand new blueprint formula, y equals 7 minus 2x. Here is where the magic happens. The book tells us, substitute this expression for y into equation 1 and solve to find x. Think of it like a game of basketball. We are benching the player y in equation 1 and subbing in its identical twin expression, the entire quantity 7 minus 2x. Now look at our newly formed single variable equation, 3x minus 2 times the quantity 7 minus 2x equals 0. Let's break open the walls of the bracket by distributing the minus 2. Be super careful with the signs here. Minus 2 times 7 gives us minus 14. Now for the ultimate algebraic trap where most students lose points. Multiply the minus 2 by the second internal term, minus 2x. A negative times a negative always creates a positive. So, minus 2 times minus 2x becomes a positive plus 4x. Our full expanded line is now 3x minus 14 plus 4x equals 0. Let's tidy up our work area. We have two matching members of the x family sitting on the left side, 3x and plus 4x. Let's bundle them together. 3 boxes plus 4 boxes gives us 7 boxes total. The line simplifies down to 7x minus 14 equals 0. We are getting so close. Let's isolate the x, move the minus 14 across the equals sign to make it positive 14, giving us 7x equals 14. Now, divide both sides by 7 to crack open the variable. Look at that, x equals 2. We found our first answer, but we aren't done yet. The book reminds us, find y from equation 2 using this value of x. Let's take our fresh value of x equals 2 and feed it right back into our initial isolated equation 2 blueprint container. Let's calculate the arithmetic line step by step. 2 times 2 equals 4. So our equation becomes y equals 7 minus 4. Subtract them cleanly, and boom! We get y equals 3. The textbook explicitly states our final solution pairs. The solutions are x equals 2, and y equals 3. A true mathematical professional always verifies their field data. Let's test our answers simultaneously against both original equations to be 100% certain. For equation 1, 3 times 2 minus 2 times 3 equals 6 minus 6, which equals 0. True. For equation 2, 2 times 2 plus 3 equals 4 plus 3, which equals 7. True. These values satisfy both equations. Stop guessing and start visualizing your algebra steps with flawless structural logic. Hit that subscribe button right now, turn on notifications, and come hang out for your daily conceptual breakthroughs at my Brainy Cave.